Okay, my friends, we are in 14.2. We're looking at page 485. We're talking about diluting molar solutions. Shh. So I've got up here on the board for you, this is a simulation that is showing you molarity. You see over here on the right, we've got solution concentration. So because we have a half mole of solute and a half liter of solution, when we divide those things, we get 1 molar of concentration. Make sense? If I want to dilute this mixture, are you comfortable that I would just simply add water to it? If I add water to it, what happens to the molarity? Does that make sense? I haven't changed the amount of solute I have. I've simply added more water. Drink mix. If I go back, so here's at my 1.0 molar, right? If I go and add less water, what happens to my concentration? It goes up. So I'm up to 2.5 molar now. And this is kind of like duh, but visually it helps. Okay? Let's change our substance now. Oh, before I do that, set it back to the middle here. Let's change our substance. Okay? It doesn't really matter which one we pick, but we'll pick copper sulfate because we used copper sulfate, right? We dissolved this guy, we did some work with it. So, how about we increase our amount of solute? Let's go up here to 8.1 moles. Again, in about half a liter of solution, that I guess 598 milliliters of solution, and we're at this 1.3 molar. Are we cool? But if I lower the amount of water I have, do you see what happens at the bottom there? It's saying, hey, this solution is saturated. Remind me, what does that mean? Can't hold any more. It's totally full of solute. So even if I keep adding more, right, I'll take it back up so it's not saturated anymore. But if I keep adding solute, right, it won't go in. Yes, sir. Right. There's no more space. We use the analogy of seats, like in a Ring Around the Rosie or what's that other game? Sorry? Sure, like a movie theater, sure. But there's no seats left. Musical chairs is what I was trying to come up with. Thank you. Yeah, there's just not any chairs left for them to sit on. There's not enough water molecules left to bond. Absolutely. Are you with me, my friends? And that amount will change based upon what we have, what we're dealing with, right? Like here, copper nitrate, or cobalt nitrate, excuse me, is not saturated with the same amounts. Are you with me? So this same molar solution is not saturated. I would have to go way down, and even then, I can't make this solution saturated with the parameters they gave us here. Are you with me? I could add more solute and it would work. Does that make sense? So what we're doing today is just very straightforward. We are wanting to calculate, if I dilute something, what is the new molarity? And the equation is pretty straightforward. It's simply my starting molarity. So this, use a different color. This is molarity. And this is, anyone? The volume. Remember, because in all of our problems I would say, you have 1.5 liters of 3 molar, and then tell you what it is. Right? So we need to know both of these things, how much I have and what is its concentration. So and this is by 1 and 2, sorry, let me change colors again. By 1 and 2, I just mean here's the molarity and volume I start with, here's the molarity and volume I end with. And if I know 3 of these things, I can certainly find the 4th. If I start with a certain molarity and a certain volume, and I want to know how much fluid do I have to make to get this new molarity, we could figure that out. So let's try. So, and basically I'm looking right at example problem number 3 on page 486. So if I have a 2.00 molar solution of calcium chloride. Oh, sorry, that's what I want to get, is a 2.00 molar solution. But I have 0.5 liters of a 0.300 molar solution. And I want to know what volume in milliliters of a 2 molar solution would you use to make a half liter of 0.300 solution? Are you with me? So we're starting out with this, right? But I don't want a 0.3 molar, I want a 2.0 molar. I want it to be more concentrated. Are we cool? And they want to know, well, what volume then should I have had? Cool? All right. So, are you comfortable that we are going to solve? Right? We're going to solve for these. So, does it matter which ones you assign as 1s and which ones you assign as 2s? It doesn't. Okay? Usually whatever they give you 2 of, I'll put as 1s. It doesn't really matter. Okay, the example problem, they put them both as the 2 that you knew over here as 2s. It doesn't matter. It doesn't matter. But we keep them together, right? So, we'll follow what the example problem has here just so we don't confuse you. They're calling this your volume 2 and this your molarity 2. Here's my molarity 1, and I'm trying to find V2. Oops, I'm sorry, not V2. V1. Are y'all with me? I want to solve this equation to get V1 by itself. How would I do that? Divide by M1, right? So therefore, I'm going to have that V1 is equal to V2 M2 all over M1. Can we do the math? That 0.5 is multiplied by 0.300. I divide that number by 2.00. Right? And when you do the math, you find that V2 is equal to, and you can do the math, but it's here right in your textbook. It comes out to be 0.0, oops, not 00, 0.075. What units are we in here? Well, what do we start here with? With liters, right? Okay, but it doesn't want liters, right? What does your textbook ask for? Milliliters. So I multiply that by 1,000, and I get that V2 is equal to 75 milliliters. Does that make sense? We have a volume and a molarity that are paired together, right? In this case, it's 0.5 and 0.300. Those guys go together. And I have either a molarity or a volume on the other side, and one unknown. And I simply just solve for that unknown. Pretty straightforward. Questions there? Please. It did tell you in the problem. Yep, yep. So no, if they don't tell you, if they just ask what volume, sure, you can use liters. That's fine. Liters is a volume. Okay, I'm sure you can decipher where you're going here. in 14.2. It is page number 486. It is numerellos 24 to 26.